Hello and welcome to lesson 5R. I can find the volume of solids. Now this is all review for you guys. You learned all of this in middle school. It's just waking up the brain. The volume of a prism or cylinder can be found by always using the formula volume equals base times height, where capital B stands for area of the base. Notice that's different than lowercase b, area of the base, okay? And as always, your base must be perpendicular to your height. So these kinds of problems, there's usually a little bit of work we have to do in order to find the base before we could keep going. So for example, here's a prism or a cylinder. I'm going to call this side 10 and this side 4. Now there is a formula for this if we wanted to plug things in where volume equals pi r squared h for a cylinder, but in reality, the base in this is a circle, which is just pi r squared. So all we did was we just plugged pi r squared in for capital B. So that's really what I'm always going to do. So if volume equals base times height, and my base is the area of a circle, which has the formula pi times r squared, well, I'm going to plug in pi times r is 4 squared, which gets me 16 pi. Okay. And then we know that my height is 10. So volume equals capital B, which we found to be 16 pi times a height of 10. Well, that means I get 160 pi, and this is going to be units cubed. And when you leave it like this in terms of pi, that's known as the exact answer, not the approximate. And so we usually like to leave things in terms of pi unless if they tell me to find the approximate answer. Now let's take a look at this guy over here. Over here we have a triangular prism. Now when you look at this, the base of this figure is in fact the triangular face. So my base here is the triangular face. The base is not necessarily what something is resting on. The base is whatever we would use to help us name the figure. I know this is a prism. What kind of prism? A triangular prism. Therefore, my base is a triangle. Now, that means that capital B is going to be my formula for area of a triangle, which equals 1/2 base times height. Now, be careful. This base and height are different than the base and height in my volume formula. This height is the height of my base, which is different than this height here, which is the height of my solid. And this lowercase b right here stands for, it's a length, it's a linear measurement. It's the length of the base of my triangular face. It is not the same thing as capital B. Clearly it's not, because we need lowercase b in order to find capital B. So my capital B, when I look at this triangle, the base is this segment right here, which I can pull from over here is 11.1. So it's 1/2 times 11.1, and my height has to be perpendicular to the base, as always. Well, it must be this right here. That's the height of the face, the height of that triangular face, which is 6.2. So when I plug that in, I get a capital B of 34.41. 34.41. That is the area of the face of the base. Now let's plug into the volume formula. Well, volume equals capital B times H. Well, capital B we found was 34.41. Well, H stands for volume of my solid. Well, volume of the solid has to be perpendicular to the face that is the base. Well, a side that's actually perpendicular to your triangular face is this 14.7. That segment there is perpendicular. We could even draw a little angle up here, right? To show that's perpendicular to the triangular face. So that is the height of my solid. So I'm going to do 34.41 times 14.7. And when I put those in my calculator, I get that my volume is in fact 505.827, and my units are millimeters cubed because we're looking at volume. And guys, I don't know what my pen is doing. It's jumping all over the place. So that's our volume formula for a prism or cylinder, basically anything that goes straight up and down, right? Whereas our volume formula for a cone or a pyramid, basically anything that comes up to a single vertex, is really, really similar. It's still base times height, but then we just multiply by that 1/3. Our base is still perpendicular to our height, and B stands for area of the base. All that hasn't changed. So let's look at some examples here. My next problem down here, I've got a pentagonal pyramid. It comes to a point, so I'm going to use volume equals 1/3, area of the base times the height. Well, my base is a regular polygon. Remember our regular polygon formula? Probably not, we'll remember it though. Regular polygon, that's equal to perimeter times apothem over 2. Perimeter of the base times the apothem divided by 2. Well, my perimeter of my base is this 11.6 times the number of sides, which in our case is 5, which ends up getting me a perimeter of 58. The apothem is the segment from the center of my base to a midpoint of the opposite side. It hits at a right angle, so my apothem is equal to 8. So now we're going to plug back into this base formula. Base equals a perimeter of 58 times my apothem of 8 divided by 2, which gets me that the area of the base is 232. Now I'm going to plug into my volume formula. Volume equals 1/3. My area of the base we got was 232 times the height. Again, the height needs to be the segment that's perpendicular to the base. Well, this right here, this 15 comes straight down and is perpendicular to the face that is the base. That means that that is acting as my height. So my volume is equal to 1/3 times 232 times 15, which is 1,160 feet cubed when I plug it into my calculator. All right, let's look at this next problem. Over here, we have a cone. This guy is a cone. And so we're still going to use volume equals 1/3 area of the base times the height, but we're missing a few things here. My base, I can go ahead and figure out. The base in this case is really the area of a circle, which equals pi times r squared. Well, in this case, my r is this 5, so capital B is pi times 5 squared, or 25 pi. And guys, leave it like that till the very end of the problem, okay? Well, so we've got our B, it's 25 pi, but I don't have an h, because that 13, that's not the h, that's my slant height. And if you notice, it is not perpendicular to the base, so it cannot act as my height. But if you look here, this actually makes a right triangle with a base of 5 and a hypotenuse of 13, and we're just missing this h. So I can use Pythagorean theorem to help me find h. So I would do 5 squared plus h squared equals 13 squared, where I get 25 plus h squared equals 169, h squared equals 144. So my h is 12. So this side length right here is in fact just 12. So now I can plug into my volume formula because I've got everything I need. Volume equals 1/3. We found capital B was 25 pi. And we found that the height here was 12. When I work that out, 1/3 times 12 is 4. 4 times 25 is 100. I get 100 pi. That's my exact answer, right? So 100 pi units cubed is my exact answer. Whereas if I want the approximate, I plug into my calculator and I round. I'd get 314.159 units cubed, and this would be my approximate answer or rounded answer, right? All right, guys, that's the end of this section. And for that matter, the end of Unit 5. Go ahead, make sure you've done everything in your book. Make sure you've got all your constructions done. And once you are done with your book, you may turn it into your teacher. Thank you very much.